Electrolysis of aqueous copper 2 sulfate solution. In this process, aqueous copper 2 sulfate solution is the electrolyte and 2 platinum rods are used as electrodes. This solution contains CuSo4 molecules and also contains H2O molecules because of the presence of water. CuSo4 molecules decompose into Cu2+ ions and SO42- ions. H2O molecules into H+ and OH- ions. These ions are freely moving in the solution. Electrodes, wire, and battery are set up as shown in the figure. Cu2+ ions and H+ ions are positive ions, cations, and they move to the cathode, which is the negative electrode. SO42- ions and OH- ions are negative ions, anions, and they move to the anode, which is the positive electrode. At the cathode, between Cu2+ ions and H+ ions, only one of the ions will be chosen and will receive electrons from the cathode and be discharged. In deciding what will be the reactions at the electrodes, there are 3 factors influencing the electrolysis products. They are position of metal or group in electrochemical series, concentration, nature of the electrode. In electrochemical series, cations and anions are arranged in the order of increasing readiness to discharge at the electrodes on passage of electricity. The lower the position of ion in electrochemical series, the easier to discharge the ion. In electrochemical series, the position of copper ion is lower than that of hydrogen ion. So, copper ion is easier to discharge than hydrogen ion. Copper ions receive electrons from the cathode and then deposit at the cathode as copper atoms. Similarly, according to the positions in electrochemical series, OH- ions is under SO42- ions and is easier to discharge. OH- ions give off electrons and discharge at the anode. From every 4 OH- ions, 1 oxygen molecule and 2 water molecules are formed. As a net result, copper is deposited at the cathode. And oxygen gas is evolved at the anode.